Hi all the students. Today in the unguided media or in the wireless transmission we are going to study the radio waves or the radio transmission. So before we proceed with radio waves or radio transmission, there are two important terms that we all must know. One is your frequency and other is your wavelength. So before we proceed on to the radio waves or radio transmission in the wireless transmission or in the unguided media, we must know two terms very clearly. One is your frequency and another is your wavelength. So what is frequency? Frequency is the number of occurrences of a repeating event per unit of time. That means in a single unit of time, an event has repeated how many times? The occurrence of that event or that event has been repeated how many times in a unit of time is your frequency. Now if I look at this waveform, it starts from here, goes on and then ends here. So what is the frequency of this waveform? Now first of all, these rising waves, the top of the rising waves is known as the wave crest, and these low waves, falling waves, are known as the wave trough, right? So this is the crest and this is the trough. So what is the frequency in this case? How many times this wave has been oscillating? The wave has oscillated one. This is one complete oscillation. It starts from here and ends till here. That means this is one complete oscillation from a rising wave to the falling wave. From the starting point of the rising wave to the end point of the falling wave is one oscillation, right? So in that case, how many oscillations are there? This is one oscillation, right? Then this is another oscillation. So how many oscillations in total can you see here? This is one oscillation, and from here till here this is second oscillation, and this is half of oscillation because this waveform has not been completed. So this is half oscillation. So one oscillation here, one complete oscillation from here to here, one complete oscillation from here to here, and half oscillation from here to here, right? So you have two complete oscillations in total, one complete oscillation plus one complete oscillation, two complete oscillations plus a half oscillation. That means in total how many oscillations you have? The number of oscillations that you have is 2.5. So in a unit of time, that means in 1 second of time, the number of oscillations that were there in the waveform were 2.5. Therefore, what is the frequency of this particular waveform? The frequency is 2.5 Hertz. So this is how you find out the frequency, and this is what exactly a frequency means. That means how many times this event has been repeated. It has been repeated once, it has been repeated twice, and then half. So 2.5 is the frequency of this waveform. So this is what we call frequency. Then if I talk of the wavelength, what is the wavelength? Now clearly from one crest to another crest or from one trough to another trough, right? So this is basically the distance between adjacent crests or adjacent troughs of a wave motion. So if the wavelength is the distance between the adjacent crests or adjacent troughs of a wave motion. So in this case, if I look at this waveform or this wave motion, so in that case, wavelength is the distance between any two adjacent crests. Like from here to here is the wavelength, from here to here is the wavelength, or any two adjacent troughs. Like from here to here is your wavelength. So this is what you call a wavelength. A frequency is always denoted by small f, and the wavelength is always denoted by lambda, right? So this is the concept of frequency and wavelength in a radio transmission. It was very important for you all to know these two terms. Now let's proceed with the actual topic, that is the radio transmission or radio waves in the unguided or wireless transmission. Now, basically the radio waves are the waves which are having the longest wavelength, right? So now you know what a wavelength is. So these are the waves having the longest wavelength in the electromagnetic spectrum. The characteristic of the radio waves are that, first of all, they are easy to generate, then they can travel long distances. Of course, in communication it is always a plus point if your signals or waves can travel longer distances, and they can penetrate buildings easily. This is what we want. When we want to travel long distances, we know that we will have obstacles in between, we may have tall buildings. So if these waves can penetrate buildings easily, even better. So these are the three important characteristics of a radio waves. Now, where are they used? The radio waves are basically widely used for communication both indoor and outdoors, right? So there is no restriction on whether they will be used only indoors or whether they will be used only outdoors. They can be used both indoors and outdoors. Then they are omnidirectional. Now, omnidirectional means they can travel in all the directions. So they do not just have to travel in a straight line. They can travel in this direction, in this direction, in this direction, in this direction. That means these waves can travel in all the directions. So because of this, there is no restriction of two antennas to be aligned physically in proper alignment. There is no such restriction that you have to align these two antennas facing each other in a proper alignment, since they can travel in all directions. So there is no constraint of aligning the antennas physically very properly. Okay. Now the transmitters and receivers, obviously the transmitters are one which are transmitting and receivers are one which are receiving the radio waves. So the transmitters and receivers, as I told you, do not have to be carefully aligned physically, since they are omnidirectional and can travel in any and all directions. Now, when there are low frequencies, in a low frequency band, they can pass through obstacles easily. So when they are traveling at a low frequency, then they can travel the obstacles easily. You know what a frequency is. But when there is when there is a longer distance from the source to destination, in that case the power to pass through obstacle falls off, right? So if the distance is short and at low frequency, they can easily pass through obstacles. But if the distance is longer, in that case at low frequencies, this power to pass through obstacle falls off sharply. At high frequencies, they travel in a straight line and bounce off obstacles. So when they are at high frequencies, they travel in straight lines and they bounce off the obstacles. They can be absorbed by rain. At all frequencies, they are subject to interference from electrical equipment. So whether they are at low frequencies or at high frequencies, this is one disadvantage, that they are subject to interference from any electrical equipments. Now let's look at the bands of, or the frequency bands as we call them, of the radio waves. So starting with the extremely low frequency band, if in the which we also call as ELF. So the extremely low frequency band, or ELF, has a frequency range of less than 3 kilohertz and the wavelength is greater than 100 kilometers. In a very low frequency band, the frequency range is from 3 to 30 kilohertz and the wavelength range is from 10 to 100 kilometers. Then at low frequency bands, the frequency range is from 30 to 300 kilohertz and the wavelength is from 1 meter to 10 kilometers. At high frequencies, the frequency range is from 3 to 30 megahertz and the wavelength is from 10 to 100 meters. At very high frequencies, that is VHF, the frequency range is from 30 to 300 megahertz and the wavelength is from 1 to 10 meters. At ultra high frequencies, they have a frequency band of 300 megahertz to 3 gigahertz and the wavelength is from 10 centimeter to 1 meter. At super high frequency or SHF, the frequency range is from 3 to 30 gigahertz and the wavelength is from 1 to 1 centimeter. And at extremely high frequencies, the frequency range is from 30 to 300 gigahertz and the wavelength is from 1 millimeter to 1 centimeter. So this is all about the radio waves or radio transmission.